You know, our galaxy, the Milky Way, it isn't just floating peacefully through space. Nope, it's being dragged, pulled across the universe at over 2 million kilometers an hour by some kind of massive, invisible force. So today, we're going to play cosmic detective and hunt for the culprit in this incredible mystery, the Great Attractor.
And this is the real head-scratcher, right? I mean, we've known for about a century that the universe is expanding. Everything should be moving away from everything else, nice and orderly. But that's not what's happening to us. We're on a very specific and very, very fast trajectory. So what's causing this cosmic drag race?
Get a load of this number, 627 kilometers per second. That's how fast our entire galactic neighborhood, what we call the local group, is blazing through the cosmos. We know this by measuring our speed against the cosmic microwave background, which is basically the leftover heat from the Big Bang itself. This isn't just some random drift. Something truly massive is pulling our strings.
Okay, so our detective story begins with the very first clue. Astronomers started noticing that our galaxy's movement just wasn't following the rules. This weird deviation was the first real hint that some powerful, hidden influence was at play out there in the dark.
So, on the left, you've got what we thought we'd find, the Hubble flow. Think of galaxies like raisins in a loaf of bread that's baking. As the bread expands, all the raisins move apart smoothly. Simple. But on the right is what we actually see, this extra kick, a peculiar velocity, which proves we're not just passive passengers in the expanding universe. We are being actively pulled somewhere.
And this term right here is key to the whole investigation. Peculiar velocity is basically the speed of a galaxy on top of the normal expansion. It's the smoking gun, the hard evidence that local gravity from enormous structures can actually overpower the smooth flow of the cosmos. And our galaxy's peculiar velocity? It's off the charts huge.
So, with the evidence of this mysterious pull firmly established, the hunt was on. The big question became, what could possibly be massive enough to yank thousands of galaxies, including our own Milky Way, across the universe?
This is where our heroes enter the story. The Seven Samurai. Back in the 1980s, this incredible team of astronomers painstakingly mapped the movements of around 400 different galaxies. And their work confirmed it beyond any doubt. A huge cosmic river of galaxies was flowing toward one specific spot in the sky, over toward the Hydra and Centaurus constellations. It was actually one of the Seven Samurai, an astronomer named Alan Dressler, who gave this gravitational weirdness its awesome, iconic name, the Great Attractor. And you know, the name itself was a game changer. It transformed this thing from a bunch of data points on a chart into a real, tangible target that people could hunt for.
And what a target it was. The first guess at its mass was just mind-bending. 10 quadrillion times the mass of our Sun. That's like the gravitational punch of tens of thousands of Milky Way galaxies all rolled into one. I mean, the scale is almost impossible to wrap your head around.
But there was one massive, massive problem with finding this cosmic monster. The number one suspect was hiding in the perfect place, a spot in the sky where our telescopes were basically blind.
So it turns out the Great Attractor is located directly behind the disk of our own galaxy. They call this the zone of avoidance because it's so choked with stars, gas, and dust that it blocks almost all visible light. It's like a giant cosmic curtain, hiding about a fifth of the entire universe from our view.
So how do you find something that's hiding behind a wall of stars? Well, you have to use different kinds of light. Astronomers switched over to X-ray and infrared telescopes, which can slice right through all that cosmic dust. It was literally like putting on a pair of X-ray goggles to see what was hiding behind the curtain.
And it totally worked. Peering through the zone of avoidance, they found it, the Norma cluster, a gigantic, sprawling cluster of galaxies sitting right where they predicted the Great Attractor would be, with a mass of about 1 quadrillion suns. So, case closed, right? Well, not so fast. Just when it seemed like the mystery was all wrapped up, a huge plot twist came along and changed absolutely everything.
This became the million-dollar question. Sure, the Norma cluster was huge, no doubt about it. But was it really big enough to explain our insane 627 km/s speed? The detectives started looking at the numbers again, and they just weren't adding up.
And here's the bombshell. A really detailed X-ray survey called CISA came back with shocking results. The total mass in the Great Attractor region, including the Norma cluster, was only about a tenth of what they needed to explain our motion. The main suspect simply didn't have the gravitational muscle. There had to be another player in the game.
So, astronomers pushed their surveys even further out, looking past the Great Attractor. And that's when they found it, the true gravitational heavyweight champion of our corner of the universe, the Shapley Supercluster, a truly colossal gathering of more than 8,000 galaxies hanging out about 650 million light-years away.
This chart really puts it all into perspective. The Great Attractor region is massive for sure, but the Shapley Supercluster? It's on a whole other level, at least 10 times more massive. It turns out the Great Attractor isn't our final destination after all. It's just a cosmic rest stop. Both the Great Attractor and our own galaxy are being pulled toward the real giant, Shapley.
So now, with all the suspects identified and all the evidence on the table, we can finally map out our true place in the universe and really understand the full, amazing story of our cosmic journey.
And this brings us to this incredible new picture of our cosmic home. Back in 2014, scientists redrew the map and named our local supercluster Laniakea. The best way to think about it is like a vast gravitational watershed, a basin containing 100,000 galaxies. And the Great Attractor? It's just the bottom of the basin, the central point where all the local cosmic rivers are flowing.
It's really like a set of cosmic Russian nesting dolls. Our tiny local group is falling toward the Virgo supercluster. That whole Virgo system is then flowing down toward the Great Attractor. And then the entire Laniakea system, all 100,000 galaxies, is being pulled toward the ultimate gravitational boss in this neighborhood, the Shapley supercluster. It's just incredible.
But hang on, there's one last epic twist in this story. It's a cosmic tug-of-war. On one side, you have the immense gravity of all these superclusters pulling everything together. But on the other side, you've got dark energy, this mysterious force that's making the universe expand faster and faster. And the winner is dark energy.
What this means is that despite these unbelievable gravitational pulls, we will never actually reach the Great Attractor or the Shapley supercluster. It's kind of wild. Dark energy is pushing them away from us faster than gravity can pull us toward them. Our cosmic journey is a race that, it turns out, we are destined to lose.
So, we've solved the mystery. We figured out our peculiar velocity, and in doing so, we've revealed this breathtaking map of the cosmos, with our galaxy as just a tiny boat in a vast celestial river. We finally know where we're going. But it really makes you wonder, if a structure with thousands of galaxies could hide right in our cosmic backyard, what other giants are still lurking out there in the dark, just waiting to be discovered?